Ever since the first satellite launch of Sputnik in 1957, thousands of satellites have been launched from different countries. For over 40 years now, these satellites have built up in our atmosphere. As a result of these multitudes of satellites, space junk has become a major issue. Space junk is defined as disused satellites and other man-made debris in orbit around Earth. NASA estimates that about 500,000 pieces of dangerous debris orbit the Earth. Some examples of space junk are out-of-commission satellites, discarded bits of rocket stages, fragments of spacecraft, and astronauts' long-lost equipment. Imagine those satellites that control your GPS, TV, or basically anything regarding your iPhone stopping due to it being struck by space junk moving at 17,500 miles per hour. Here are 3 theoretical approaches to combat this space junk issue. The Swiss Space Center chose an active approach, coming up with the idea of Clean Space 1, which would capture pieces of debris with its 8 long arms. But some of the main problems with this idea is that it would cost $11 million to fund the project, and it would be extremely difficult to identify whose junk was whose. You wouldn't think it would matter, but the Outer Space Treaty, which governs international space law, says you can't touch satellites or anything else that doesn't belong to you, whether they are in operation or not. The U.S. Air Force came up with their own defensive approach called the Space Fence, which would use powerful S-band radar system and high-frequency wavelength to enable it to spot smaller chunks of debris. Using continuous radar pulses, this fence would then detect and track orbits of objects as they pass through the field. Lastly, the Defense Advanced Research Projects Agency came up with the recycle approach, where they could salvage and reuse components in order to rebuild decommissioned satellites, with the goal of reducing the need for new satellites to be placed into orbit. Although there are many valid plans to reduce the amount of space junk in the atmosphere, the reality is that these technologies will take much time and money to produce, and more scientific advancements are needed for this to happen.